And right now you are seeing the presentation in your individual screens. However, I believe Dave has a screen set up so you all can see that presentation on the projector. Is that correct, Dave?
Yes.
Okay. So definitely having your second screen is going to be very beneficial. If you're working on a piece of equipment, you can see what's being presented on the projector, and then you can follow the steps on your individual screens. So I'm going to start sharing. So let me know if everybody's able to see my screen.
Yes.
Okay, awesome. So we're going to do a review on BTT2 IPC. I know that once the meeting was created, there was an additional ask. I saw the communications between Chris and the other leaders if we could actually just do a quick review on also analog region. We'll see how the time allows for us to actually cover part of that also. But the main focus is going to be on IPC, which is going to include edge marks and also switches and phones. So the first module that you're looking at right now, which is your module number 6, that is going to include your IPC that is going to cover session border controllers. So in this lesson, we're going to see what voice manager is, what session border controller is used with IP-centrics. It also goes a quick overview over power over Ethernet. We talked about configuring an HMark and how to use optics. Now, it's not going to go into very details in optics, but if there is a IPC that is being installed over fiber, optical internet or active E, there is a static IP that is just added in optics. So the HMark can be configured with that static IP. So that's the part that optics covers. So the objectives of this lesson are to be able to explain what is the difference between VoIP and Cox Business Voice Manager product. Define what Centrex is and what it does. What is the session border controller? I know we always use the common language, session border controller is an HMark. The HMark is the brand of the equipment, but the actual equipment is called a session border controller. Then we see the list of IP-centrics and how does it communicate with the session border controllers. We'll talk about the different topologies, how to configure the session border controller, in this case, the HMarks. There are different versions of HMarks, like the 2900, 2900 PoE that has the embedded switch, some older models like the 4500 or the 4700 models, they all get configured the same way. Then we'll cover a portion of going through optics and finding fiber-fed HMark static IP addresses. You guys have any questions about what are the objectives of this lesson? And please, if you have questions, speak up. You can also use the chat to ask some questions. There will be some questions that will be asked as a review, and I will engage the chat so we're able to communicate. So let's jump right in. We're going to do a quick overview of what Cox Business Voice Solution is. So when we think about Voice Manager, what do you guys know about Voice Manager?
Product that we use for regular analog.
What was that, Christian?
That's the product that we use for.
That's the product that we use for regular analog.
Okay, correct. That's correct. So when we're thinking voice manager, I want you guys to think that it's not necessarily our POTS line. Voice manager, even though we call that our traditional POTS lines, voice manager is actually the product. So voice manager, that's why it says it's a fully hosted solution. That includes POTS lines, that includes IP-centrics, and there are other advanced video voice products that include SIP and PRI. They all fall under the voice manager platform. So voice manager is the platform, not just the actual voice lines that we're installing. So when we think voice manager, think about how we are delivering voice services to our customers. A lot of questions people get asked, so is voice manager VoIP? Okay. And the conversation is, well, we're using a data technology or packet technology to be able to send voice. So it is similar to VoIP. However, we use VoIP not as a service, but as a technology. So VoIP is the technology, not the service. So the way that VoIP or voice over internet protocol basically converts an analog voice into packets and then is routed over an internet protocol without having to rely on the traditional circuit switch technology. So, right, voice over IP, voice over internet protocol, but it's not that we're routing our voice traffic to the internet. Our voice manager platform really is our VoIP system that fully monitors and ensures that everything is working, how calls are routed, the features that it has so the customer can manage its systems. So, for example, voice managers uses real-time streaming protocol to be able to route the customer's phone calls. So as we look at the VoIP architecture that Cox uses, VoIP is really being hosted, or voice manager is being hosted by our BroadSoft host servers. Okay. Customers do not know the product as BroadSoft. We know it as voice manager. But our BroadSoft host servers, they manage all the features that our voice manager service has. The advantage is with this is that we can use an EMTA and use voice manager for POTS lines. We can use a cable modem and provide voice services for advanced voice products like SIP and PRI. All that voice analog sound gets converted to data into packets, then it's routed through our CCAP or CMTS, goes through Cox private IP network. Cox IP network then routes all the communication between the BroadSoft host servers and also our configuration or policy servers. The customer also have access to our BroadSoft host servers. Now, the application that the customer interfaces with BroadSoft, we call that My Account, or the customer's My Account. A technician actually has access to some of those BroadSoft host servers applications, and we call that My Admin. So all calls are routed to Cox VoIP IP network, and then they're routed to the rest of the public switch telephone network. If a customer is generating a call from any of our markets, Nova, Hampton Roads, and they are not calling, they're calling within a Cox customer, the call stays within the Cox network, never leaves the Cox network. The only time the call will leave the Cox network and go to the public switch telephone network is when the end user or the customer that we're calling or the individual we're calling, it's not a Cox. some of the equipment you are familiar with already. So here we have EMTA. So in EMTA, we use it traditionally to install what we will call a digital phone line. That includes a line that the customer is going to use for a fax machine, credit cards. Everybody's familiar with the LEDs on the EMTA TM804. The back of the unit, very familiar of the RJ11 ports. Now, the EMTA can't do both data and voice. However, we do not use it to output internet to for our customers' data network. Right now we only deploy it for telephone lines. This one goes over a couple of installation. Just a reminder, we want to make sure that all of our equipment is always mounted. Sometimes the customer might ask, so why do we want to make sure that all of our equipment is mounted? Well, it's installed professionally, but also when we mount the equipment, there's a less chance of service interruption because the equipment cannot be unplugged by mistake, or somebody can unplug the phone lines. It's in a secure location. So there's a lot of benefits for us mounting our equipment. A good call out that I want to emphasize on this module is that our voice manager lines sometimes are going to be connected to customers' PBX. The public branch exchange equipment, that is customer-owned equipment. We do not work on customer equipment, or technician does not work on customer equipment. Now, there are so many different models of PBXs out there. When you see them, you could see models like Avaya, NEC, Panasonic. One of the things I like to call out is that when the technician is connecting to a phone jack and they're using your toner, that could be your by Fluke, or that could be your Greenlee toner. There's two LEDs on that tone generator that indicates if there's an active line on that phone jack. There'll be a green LED if you have an active line. There could be a red LED also if there's an active line. When there is that jack is connected to a customer's PBX, it actually would turn amber or orange. Those colors, depending on which toner you're using, they might look the same. But that's an indication that that jack is actually connected to a PBX. Do not generate a tone if that is going through a PBX. That's where the customer will need to engage their phone vendor to remove that line out of their PBX and make it available so we can connect a voice manager line. Maybe they want to use that jack for fax or credit card machine. So a good call out. Don't troubleshoot beyond the demarcation point, especially when there's a PBX present. Do not push a toner onto lines where a PBX is present. Okay. There you go. My display froze for a second. There is a video embedded on how to install an EMTA, how to work with 66 blocks. That's what that video is. We're not going to play that because we want to jump right into what we're here for. Before I continue, what kind of question do you have of what we covered so far? I know it's just a review on some of these items, but any questions? Oh. Okay. with my presentation. That's the one I'll jump easily to the next slide. Okay, so we're going to take an overview of explaining what Centrex is and what's the difference between Centrex and IP Centrex. So Centrex is basically the emulation of a PBX. Now, in this case, Centrex is actually the software that is used at a central office to customize how the calls are routed within a customer's phone communications. So just like a PBX, as you see in this image, nodes within the group call each other using 3 or 5 digits rather than an entire phone number. So that includes like dialing by extensions. Other features that Centrex allows is that they can go directly for dialing or DID. They can do call forwarding, conference calling. They can do call pickup groups. So think about Centrex is a PBX, but the software side. So when we say IP Centrex, which is our product, IP Centrex is a combination between the central exchange, kind of like a telephone exchange. It provides the functions similar to that PBX, but it's provisioned with equipment owned and located at the service provider, in this case, Cox. IP Centrex take the control really to a next level because an IP Centrex service can be located anywhere. Clients can simply use standard broadband IP connection to connect to the network, and the service provider can deliver the PBX emulation directly to the IP phones. So if we're thinking VoIP technology with Centrex technology, so IP Centrex is the implementation of Centrex, but using VoIP. Sorry, my mouse is not cooperating right now. So that's what I'm waiting for my mouse to transition. As you see in this image, when we install IP Centrex, we install a backhaul right here. Then we install a session border controller. So a session border controller is a device deployed at the border between the customer's private network and the public network. It securely and efficiently transfer phone or voice data traffic from the IP network or the public network to the customer's private network. A communication using a session border controller is called a session, and it's a real-time stream of communication between 2 or more users. Now, we use IP Centrex for voice. However, the capability of IP Centrex can include voice call, video conference, instant messaging, because it's using a protocol that we call SIP, Session Initiation Protocol. And that session can include audio or video, also as other additional information. So the controller controls all the traffic, all the phone calls that are coming in, and then routes that traffic through the switch. The switch, all it's doing is providing PoE to the phones. And if there's any additional information that is passed through the switch, like data or management traffic, they are separated in different virtual lanes. before we move on from, any questions about what you see on the screen of everything that we have covered so far? So in your participants guide, there is an activity so we can perform a scavenger hunt to understand some of these individual terms. You will have access to all of this information. So really, you're engaging the participants to go ahead and use their resources to find what some of these terminologies are. We're just going to go right through it. So when we say a seat, we're really saying it's a single individual phone that is comprised with its own login and password and their own direct number. So all of our IPC phones, they all have their own individual numbers or their own DID. A call path, right? A virtual lane for your voice traffic to the outside world. So when customers order IPC, they also pay for call path. The number of seats corresponds to the number of phones that the customer is going to have. But the number of call path corresponds how many calls the customer can make at any given time. Typically, if the customer has 2 phones, they're paying for 2 call paths. If the customer has 3 phones, they're paying for 3 call paths. Once you start going to larger installs, 10 phones, 20 phones, 30 seats, they're not paying for 30 seats. They probably are paying for 10 call paths. So seats and call path, very rarely they match. Typically, you're going to have a higher number of seats and a lower number of call paths. Some of the additional features that IP-centrics have, like unified messaging, in which the customer can notify by email if they have a voicemail. They don't have to be hearing their voicemail on their phones or be physically at their desk phone. They can access the voicemail anywhere, as long as they have an internet connection. Unified communications, the ability to make and receive calls either on a seat, on a phone, on an application through a cell phone, or using a laptop. Call flow, every IP-centric order has a call flow. How the customer likes the calls to be routed. So it's the overall design. If the customer has an auto attendant like you see out there, an auto attendant is just how calls are routed. So when someone calls in, do we want to call sales? Do we want to call billing? Do we need to call receptionist? The auto attendant does all those functions automatically. The call flow can also include a hunt group. A hunt group is how calls are distributed. Maybe on the call flow, the customer has, okay, when you're calling in, you're going to call the receptionist first. And if the receptionist doesn't answer, the calls are automatically going to ring to 2 other desk phones so they can answer the phones. Or they can have it that if they call the auto attendant first, but then if the customer doesn't answer, the calls go through voicemail. That could be the hunt. So your call flow is the overall design. The auto attendant or the hunt group is how calls are routed into different groups. Any question about the terminology that just went over? You already have been installing Voice Manager. Have you guys worked on maybe a customer that has 100? Yep. Okay. What about a customer had an auto attendant? Kind of like that virtual receptionist. So similar features that you already are have already working with installing standard voice manager lines, it also transitions into IPC with more control. Up next, we have really an activity, so you can, when you're delivering the course, you can communicate with the technicians. Okay, we're going to match the term to the definition, something that we just went over. This is important for information retention. So when the technician is speaking to the customer, they understand the language that they're speaking. Okay. So let's do this quick activity. Information that we just went over. The first one says call flow. Which of the terms match the definition? So which will be the definition for call flow? You guys can unmute or use the chat. I see Walter's trying to kind of push an answer there, but he's just waiting.
Was. I didn't know I was.
I'm just looking at you. I'm like, you're looking closely at the definitions, and I'm just waiting to see that letter come out of your mouth.
What is the first letter to start with?
What was that?
Nothing. Nothing.
Okay. So the first call flow, that's A. That is your overall design on how calls are routed. Okay. Second one, call path.
G.
Right, okay. That is G, right? It's pretty much a virtual lane of how voice traffic are routed to the outside world. Okay. What about hunger? Okay. Hunger. Okay. It's a way to distribute calls automatically. Multi-level auto attendant.
Daddy?
That one is, sorry, it is he. So that virtual receptionist allowing the callers to navigate who they want to speak to. Press 0 to talk to the receptionist. Press 1 to talk to billing. Press 2 to talk to sales. Okay. Now a seat.
C.
Right? A C is a single user's identity. They have their own DID, or in this case, their own phone number. Okay. Unified communications. F, yes, correct. So the ability to make and receive calls either on your seat, which in your seat is really your phone, your desk phone, or it could be on a tablet, a laptop using software. That's what we refer to unified communications. And then unified messaging, right? The one we have left, that will be D, voicemail to email. The customer can listen to their voicemail. They will be notified via email. And they usually will have a WAV file that they can listen to their voicemail through their email. Or if they log into their account, they can then listen to their voicemail. Now, when IP-Centrics is installed, we install 2 types of seats. One is called a professional seat, and one is a select seat. A professional seat is what a technician will be installing. You can have a dedicated voice network connection. If it's over HFC, it's going to be over a CBI connection. If it's over fiber, it's going to be a POI circuit. If it's over XGS-PON, GPON, that means we're going to have an ONT. And then we have our session border controller. Our session border controller, it's really what manages the traffic from the IP public network through the customer's private network. Then you're going to have a LAN switch, wiring, and IP handsets. A select seat runs over the top, meaning that the customer gets shipped a phone, and all they have to do is the customer is plug that phone to their own data network. That could be their own router, their own switch. Normally, customers do self-installs for select seats. If they do trouble calls, they also do self-trouble calls. Technicians are not typically routed for installs or trouble calls for select seats. They're designed to be self-installs. So here's what a select seat might look like, and this image is very broad. You have the customer's WAN connection. That could be the customer's own switch, and then a VoIP phone. That could be the 310, the 410, the VDX 500, or any of the IPC phones. There's no H mark involved. There's no backhaul that is installed by us. The customer as select seat can also be run over other providers' internet. The phone just needs internet connection.
Are we providing the power supply to that?
Yes. So this is the and Walter, very good question. When the customer receives the phone, they actually get shipped with an installation guide that looks similar to what you see on the screen. How they're going to connect each device, the headset, the Ethernet from their router, if they're going to connect internet to that phone, to their laptop, and they also have a 48-volt power supply.
Is there any minimum number for phones the customer to qualify for select seats?
You broke up a little bit, Christian. You said the number of calls?
No, I mean, for number the seats basically. How many seats the customer qualify to select seats? Or
so the number of seats if they're going to do for select seats. Really it depends on the customer's let's say on the customer's needs. There are some IPC installation where the customer has multiple select seats. They might have an office setup that a technician does a professional install, but then they have remote personnel that they work from home, and they can have multiple select seats in different locations in their homes.
So it's not a matter of make the product cheaper for the customer.
Well,
It's
there
just,
is. Remember, Kip, there are some contract agreement that they have to go through. And if we're not providing them a seat, that it's probably a little cost effective for the customer to have a select seat, since we don't have additional hardware like the switch or the session border controller. But this device is designed to be installed at a customer's home, not in a professional office. Very good question. So with select seats, customer usually do their own support. When they call Cox Business Care, Cox Business Care will troubleshoot the issue with the customer. They will go ahead and also, if they need a replacement phone, they will ship the phone to the customer, and then the customer can ship the defective phone back to Cox. A professional seat, that's where a technician will go in and install a backhaul, such as a modem, a CBI modem. Then we install a session border controller that includes a switch. There are different versions of session border controllers. We do have one that is a 2900 PoE that if you have less than 10 seats, you can have a HMark with a switch combined in the same equipment. If it's more than 10 seats, then you will see a session border controller and a switch separate. And then the customer can have any combination of IP phones. They can have Cisco, Polycom, or a combination of the both. Typically, when you go to a customer's business, you only see one model of phones. But the system is sold in a way that the customer can customize the types of phones and models that they can have. Okay, any questions about the professional seat or what you see on this slide?
I have another question about the select.
Yep, go ahead.
What's the minimum speed
I'm sorry?
customer needs? What's the minimum speed the customer needs to provide?
Oh, wow. The minimum speed. So for the actual phone to work, you only need about half a meg. And that is for like a full professional installation. A select seat can run off DSL. It can run over LTE. Very minimum connection. Yep. So in this image, if a customer connects their laptop, they're going to get the speed that they're subscribing through the service provider. If they're getting 100 over 20, they're going to get 100 over 20 off the port on the phone. The phone is not going to reduce the speed that they're going to be connected to. It's just going to work as a switch to pass the internet traffic to the customer's laptop. Now, this chart here will give you some standards on some minimum quantity that can be ordered in order to install a customer the service. So for example, if the customer wants a mobile seat or a select seat, they can order the service for a minimum of 1. Now, if you notice, a mobile seat is really a application that they can use to make and receive calls. They do not have to have an actual phone from us. That is a mobile seat. A select seat, yes, that IP phone is an optional, but they can run a select seat right off also their cell phone through an app. Both mobile and select, they run over the top. I mean, they can have their own individual network that they connect. Now we have what we call our professional. We used to call it complete, and now we call it professional. Those do have a minimum. So if you go to a customer's office, you should see a minimum of 3 seats. They do have some contract agreement. There are minimum terms. And then the customer can use any combination of IP phones that they would like to use. We also have an analog That's typically installed with a professional seat or a professional installation in which the customer can use an ATA or an analog terminal adapter to convert an IP line, an IP phone line back to analog. In some rare situation, the customer might use this for like a fax machine. Or the customer might use it to be able to control maybe an entry to a secure door, like a door king, they call it. The customer could use that additional analog line to be able to have a wireless headset that they have on their own, so they can transfer their calls and they can move around on their office without being attached to an actual desk. Okay. Any questions about this chart that you see here?
I start, see on the last one, analog at the bottom, only ATA, what that mean?
Analog was analog ATA analog terminal adapter.
Oh, okay.
We used to see a lot of these ATAs being installed when our IP conference phones were analog, meaning they were not IP. So we needed to install an ATA to convert the line to analog and then connect a conference phone. Now that we do have IP conference phones, there's not a whole lot of need for ATAs. We will see when we look at the different voice devices, you will see what some of those ATAs look like. Okay. Again, bring in additional discussion with the technicians. If we are to roll to a self-install issue and we find that it's a select seat, what do you do or what do you say? Now, what we're driving here is that emphasize the fact that the customer do self-installs for the select seats. Now, if we're going to a customer's home to troubleshoot a select seat and they have our internet and the issue is Cox internet, we are trained on how to troubleshoot Cox internet. But as far as troubleshooting the phone, you can engage the comm center, so the comm center can engage CD care and they can work with the customer so they can drop ship another phone if they need to. Provide education about the phone, but not necessarily swap the phone. Okay. So let's do this quick knowledge check before we move on. So question 1 says, select the item that applies to IP-centric select seat. Is it A, B, or C? What was that? I heard B, Walter, so I'm gonna say B. Yes. Select seat, they run over the top. We provide support just on remotely, not on site. Now, Cox does not install a separate local area network just for select seat. No, the customer uses their own network. We don't have a dedicated voice network connection. We don't have a session border controller. So, let's look at question number 2. What is a session border controller? What is an SBC? D, yep. Is a device deployed at the border between the private and public networks that securely transfers data.
Got a question. The SBC, is that something that Cox will always program? Figure?
Yes. So the session border controller, normally when the customer order IPC, and we'll go over that later, we a order is being sent to WWT, who actually configures the switch, session border controller, and the phones, and then drop ships the equipment to the customer. Then the technician goes on site and install it. Now, in this training, we're going to cover how to configure a SBC, because as a technician, if a trouble call is generated and we are on the customer side and the issue is the session border controller, a technician can log into that session border controller and reconfigure it, put a new configuration on. So what do we know about PoE? Power over Ethernet. So keep in mind that I know some terminology might be very similar to something that we use in the field that is very different, right? MoCA uses a point of entry filter, and sometimes it's called a PoE filter. Well, PoE or power Ethernet is different. So power over Ethernet is a technology that passes electric power over twisted Ethernet cable to power devices such as access points, IP phones, security systems. PoE enables one RJ45 cable to provide both data and power through the same cable without having to have two separate cables. It uses some of those pairs to pass data and also to pass data and power. Now, because the electrical requirement is very little, it's very safe to work with this. Typically, you're looking at 44 to 57 volts DC. The phones get power from a power over Ethernet switch that provides the data and also provides the power. So the power device would actually have a signature detection that will communicate with the switch how much power it needs. There is a total budget that the PoE switches have. And it should be enough to plug all devices to all the LAN ports on the switches. Now, there are some different requirements of power depending on the device. So for example, depending on the different standards of PoE, some ports can output 15 watts, others 30, 60, or 100. It really depends on the device. Or phones use very little power. Here's an example of the different, an example of a 2900 PoE edge mark that each port can support 15 watts for a total budget of 180. Here we have a list of the different model phones that are compatible. The 6851, the 8841, Polycom 400 series, 500 series, or 300 series. They all are compatible with our the total budget that or 2,900 POE H mark can supply. Or switches are also compatible with our phones. So this is something that as a technician, they're not gonna be thinking, oh, am I gonna have enough power to power all the phones? Based on the total budget for each of the switches, with all phones, you should be able to plug in 8 phones to an 8-port switch, 24 phones to a 24-port switch, 48 phones to a 48-port switch, and they all should get the right amount of power and be able to power all the devices that connect to those switches. So, any questions about everything that we have covered? POE, session border controllers, professional seat, select seat. Nope. Okay. So let's do this. We're coming right on the top of the hour. I normally like to take breaks every 60 minutes or every 75 minutes. I think it's a good time to take a quick 10-minute break. We're gonna go over installation when we come back. So let's take a break and come back at 10:20.
Together it comes to the altar.
All the delivery team does. Got it. You do it, right? You like my magic stick? Yeah, man. It's the only way to stand. Yeah. Oh, okay, yes. I'm the training man. Yeah. Morning, how you doing?
Hi,
So this is the training lab that we have to train our field technicians on hands-on various products.
Look at how cool it is.
And when we first started, we had that wall. Very minimal pieces of equipment in here. That's it.
You didn't even have the power lines in here.
No, we didn't have any of this. And in the past year, I gotta give a lot of credit. Along with the fiber infrastructure. We built that wall, this wall to match this one. And all this equipment that you see up here is entire fiber build out.
Wow,
So like if we were building a neighborhood for a whole area, this would be what.
this is really.
And we
Now
also have
let's talk
cots.
about real simulation.
Real hands-on simulation.
That's outstanding.
Yeah. How are you doing this morning? Good. I'm Henry. Christian, how you doing? This is Cassandra, Dave. I'm sorry, Dave
And
and Dan. I got that backwards. Dave and Dan. Nice to meet you, Christian.
Yes.
So they came in and it was a year-long project because one, it had never been done before like this. So we had to figure out the process, how to get it done, how to do it in a way that not only can we do it here, but been duplicated somewhere else.
Exactly.
It's easy to tell people come in and help you do something, but it costs money. It was $75,000 originally slated for this project. We're well over that because with his partnerships with other folks, we're able to acquire some of them. When you look at this room, you can talk about it comes from the head end to those devices there, which you would have in a field to feed an entire neighborhood. It's distributed in those devices there. and feeds taps, which are these. Regular taps, fiber taps. And all those nodes that you have over there. Now, our neighborhood wouldn't have
No.
all of those nodes in one spot, but we need all of them to show the different types.
Go show.
So Dave was instrumental in telling us what we need, because he's an expert at this, and how to set us up not only for now, but for the future.
Yeah, this is awesome.
It was a tremendous effort and a tremendous partnership. Fiber team that came in and helped us out was. They had time. Yeah,
Yes.
this is all kinds of business that was sort of.
I wish you could have seen what this movie used to look
Oh,
like.
yeah.
Because you could even appreciate it so much more.
Yeah.
If you see, if you.
It was just one raggedy wall and some stuff and a bunch of junk.
I'm just thinking about just.
Real.
It's, that is.
Very tactile.
Field operations, construction, vendor partners, everybody.
We bring the sales class down here just for a quick,
Just the-
10,
yeah,
15
to-
minute
there
break.
goes the kind of-
take a look at this is, we don't get too technical,
Right,
but this is the gear that's out in the field.
But that
This is what
helps
they
them
do.
to, again, all of that just gives them that.
Instead of a guy just going up to knock.
Right.
That kind of stuff.
It helps them overcome those, can you just flip the switch?
Which one?
Just flip it. I know all you gotta do is just flip a switch. Okay, all right.
Wow. Wow, wow.
It also allows us, when we talk to the sales teams,
Yeah,
to help them understand from a technician point of view, some things we would like them to say, and maybe not say. You know, it's easy for a customer to hear something and go, this is what they need.
mm-hmm,
And really, we want to let the technician find the problem. And the sales teams, folks that work in the office, looking at stuff, tools, and coming up with some great solutions. But it can get a customer zoned in on a solution that we really want them zoned in and letting the technician fix it. It's not always what we're troubleshooting. I also gained a tremendous respect when I sat on the phone a couple of times years ago of how hard it is to take a customer from calling in to troubleshooting a product to maybe needing a trouble call, to walk through all of those steps and have them touch the TV and touch the box, and they're going, no clue what you're talking about. And these folks do this.
yeah.
That's a skill, because for a technician, we're there, we know it. We know what a TV looks like, we know what a box looks like, we're touching, having to walk a customer through that. I had a new appreciation for that. That's a lot of work. It's a lot of work. So partnership's been great. And we're still building more stuff in there.
Almost.
Almost.
Well,
I'll show you the virtual.
Oh, yeah. Oh, wait, Victor jumped off the screen. I know. Yeah. Okay.
Hey, Christian.
Yeah.
I put a folder on the chat. Let me know, can you open that folder?
Yeah, that's right.
Try to see if you can open, because it's actually a zip file since we have a lot of documents.
See, it's asking me for my email, so let me see.
Okay. And if that if you need access, I can give you access, or I can give you all access to that one since I created that folder.
Oh, yeah. Can open it up using my Cox email.
Okay. So definitely, all the modules, the two modules that we're going to be covering, the PG and the PowerPoint are in those in that file. So I'm not able to give access to the folder where Chris put the documents, but you can have access. You can have those documents from this folder.
What about the video record? How we gonna get access to that?
Once it records and I can save it, I can then share it and make it available. So what I'll do is on the same file that I sent, I'll put the video in there, and that way you guys can actually access that recording.
Okay.
Yeah.
So then I have to share all this knowledge to my team. So that's gonna be a challenge.
The module 6 and module 8 are your participants guide and also the PowerPoint, and the PowerPoint has the notes. The module 7 and module 9, those are your lab activity, kind of like hands-on.
So model 6. So there's no model 5, 4, or 3, or 1.
Well, those other modules cover other products. When we go through BTT1 training, we spend 5 days going through everything that a BTT1 does.
So
Including-
BDD is a bunch of problems.
Yes, it is.
Oh, okay.
So, and again, I'll wait once everybody's back to kind of. So you are working already on what we call CB less complex, or CTT2, which is simple CB. CBI, standard, installing a cable modem, voice manager, installing voice manager lines, and then your traditional contour and next generation contour over QAM. That's C1, C2. That's your standard CTT2 CB less complex for business. Once a technician is a BTT, that includes IPC just for voice, then includes other video products and other data products. So there's a whole lot of list of products that it encompasses, including IPC. Welcome back, Dustin.
Trying to find Jermaine some coffee. He's got to download the app.
Just share PowerPoint.
Download the app to order coffee.
Yes.
Okay. So Dustin, Jermaine, Walter, I added a zip file to the chat. Verify that you guys are able to download that zip file, and within that zip file, you're gonna have all the documents that are in that folder that Chris created, which includes the PowerPoint and the participants guide for modules 6, 7, 8, and 9, I believe. Yep. So I just want to confirm that you're able to download that zip file from the chat and have access to all those documents. Okay, Walter's shaking his head. Yeah, yep. Okay. So let's talk about the installation of IPC. Let me share my screen, make sure that you're able to see my screen. So the installation involved different phases, which include pre-sale, sales, a station review build, fulfillment, and this is where our WWT technology partner gets involved. The technician is going to be involved in the pre-install, install, and customer education phase. So that's the whole end-to-end process for selling and installing IP-Centrics. So the pre-sale is just the discovery phase where a sales agent establishes a prospect with a customer and design and agree on the terms of the contract. The sale is when the customer agrees to the service from Cox by signing the contract. Once that the pre-sale and sale is done, now we involve the station review. Now that station review, it's where the call flow and how the customer specific phone settings are going to be designed. So they're going to have an auto attendant. What kind of phones they're going to use? What are going to be the list of different users on the account? Then the fulfillment group gets involved. This is where the equipment is ordered. If we actually need construction, if the customer needs wiring, work orders are entered and scheduled with the customer. So all of that, it's done before we arrive on site. It's fulfilled the WWT, it's also part of, you can call that it's also part of the fulfillment process because WWT or Worldwide Technology, that's a group that handles the configuration of the customer's equipment, including the session border controller, switch, and the phones, and then ships that equipment to the customer site. The technician will be involved in the last three steps. There will be a pre-install order, and that includes customer going on site, installing the backhaul, let's say a CBI modem. If it's over fiber, then the COI circuit gets installed and mount the equipment, mount the switch, mount the edge mark, and test one or a couple of phones, make sure that they are working. You can test that directly to the switch. On a separate order and then on a separate day, then you have your install. That's when we actually turn up services, activate the services, and also provide customer education. Now, when we say customer education, it's a demonstration on how to perform basic functions with the phones, including making a phone call, receiving a phone call, transferring, identifying to the customer some of the additional resources that they have available. My account, the customer's My Account is a great resource if they need to know how to perform some advanced functions with their IP-centric services. So that's the IP-centric end-to-end process. Any questions? Okay. So we can install IPC via HFC and also via fiber. If we're doing over fiber, that could be Active-E or COI. That means that there will be a static IP that will be used to provision with the session border controller, and that information can be found in optics. If we're doing over HFC, that's BAU for installing a cable modem. Here we go into a little more detail, some of the roles of through the prerequisite qualification for IP-centrics. What are the responsibilities of a sales engineer? The sales engineer pretty much pre-qualifies the customer's LAN for the VoIP service. The site service determines if the customer's structural wiring, category 5E, category 6, meets the requirement to work with IPC. Normally, if the wiring does not meet the standards of Cat 5E or Cat 6, then through the pre-qualification process, we determine if the customer needs their wiring to be upgraded. Now, this is very important to be done on the pre-qualification phase because the customer and the sales engineer and the sales agent can communicate how this is going to be done, because once the technicians receives the work order, we are there to install services. Now, sometimes the technicians actually will be scheduled with wiring work orders to go and run wiring for the IPC phones that will be installed. During the pre-installation process, the topology that is going to be used is also determined. Now, when we say topologies, there are 3 topologies that we use for installing IPC. Topology 1, which is dual physical networks. Topology 2, which is a shared network with the Cox switch. And topology 3, it's a shared wiring with the customer switch. We will see a couple of diagrams a little bit later on. Topology 1 is the preferred topology because our voice services do not commingle with the customer's data services. Also, if it's less than 10 seats and you have a session border controller with a switch, the 2900 PoE, it's almost 99% of the time topology 1. If it's less than 10 seats and you have a 2900 PoE edge mark. Once you go over 10 seats and you're going to have a separate session border controller and switch, then you can have different topologies. Topology 1, topology 2, or topology 3. So here you have topology 1. The customer has their own data network. And I know here we're representing the data connection using a modem, DOCSIS 8200 modem. It could, the customer could have fiber, could have CF5 and use an ONT. But the customer has their own firewall, their own router, their own switch. In the location where the customer needs a phone, it's a jack that has 2 connections. One for their data, that's going to go to their computer. And the other port, it's going to be for our voice services or IPC, which is completely separate from the customer's data network. Here's what a professional install is going to look like. Backhaul, session border controller, switch. The switch connects to the customer's individual phone jacks for voice, and then a phone plugs into that voice jack. This is the most preferred topology. Any questions about topology 1? Topology 2. Now, topology 2, it's a shared network with the Cox switch. So if you noticed, you have the customer's data network, but then the customer does a handoff from their switch to the Cox switch. The customer can still connect any additional computers, printers, devices to their network directly to their switch. However, the jacks that are going to be connected to the IP phones and the customer is going to use to connect their own device like a computer or printer, those jacks need to go to our switch. Now, all the traffic gets tagged with different VLANs. VLAN 169 is data traffic, which goes to the customer's equipment. Voice traffic gets tagged with VLAN 269, which it's VLAN 269 is passed by our session border controller. And our management traffic, which is VLAN 369, which is also passed and authenticated by our session border controller. When the customer plugs in their computer to the IP phone, and since data it's tagged with VLAN 169, traffic flows through the phone, through the jack to the Cox switch. The Cox switch, it's configured to pass all 3 VLANs. Well, the Edgemark says I'm allowed to pass management and I'm allowed to pass voice. So it will pass all that traffic, but it will not pass VLAN 169, which is data. So the traffic gets sent back to the Cox switch and then to the customer's network. So if a customer plugs a phone to, a computer, a printer to a phone from Cox, they might just see that their network adapter just spins and spins and spins if there's no network connection from their switch. Because their switch is the one that is passing the data connection. Okay, that's topology 2. That's not that common. It becomes more of a complex installation. But just want to make you aware when you actually see the connection from the customer switch to our switch, that's topology 2. Any questions about topology 2?
When that is requested from the customer, those VLANs are pre-configured also. We have to configure.
So when we go through configuring the equipment, those VLANs are automatically configured when we build, we call the configuration. And all we do is upload the config to the switch. You don't have to manually configure them. They are automatically configured.
You said earlier there's no speed difference.
I'm sorry?
Wait, you said earlier there's no speed difference when it goes through the phone? For topology 2?
With topology 2, it's really going to be what is the speed coming from their customer switch. The phones or our phones are designed to pass 10 by 100 by 1000 megabits per second. It's really going to depend on what speeds the customer is subscribing on their data side. Yep.
Is that every phone that we have, or?
The only phones that would not pass more than 100 are going to be the Cisco SPA, which are our legacy phones, and they should already be removing those from the field. If a customer cancels those, cancels the contract or moves from one location to another, we will upgrade the SPA to the Polycom or the Cisco MPP phones, and those will support up to a gig connectivity.
In the past, they've told us that those phones would pass a gig. Would do a
Yes.
pass through again.
Yeah, the SBA model will not, but the new Cisco MPP and the VVX will.
I wonder how will be, the whole, basically, configuration, because this layout, this network layout is involving customer or firewall, and also their switch. So combined with the IPC equipment, and basically the customer is expected to have everything communicate. So it's gonna be a lot more complex.
So that's what we call this complex. Now, in the installation, normally BTT2s will be installing topology 2 or topology 3. This is probably something that a BTT1 will not be working on. I'm not sure if in your role you might be asked to support either on the installation or on the service call. But we want to make you aware how the traffic flows, because if you go to a customer's location and the issue is the phone, we're gonna walk through on how to work with the phone, how to engage with the switch, how to work with the edge mark. Remember, all of this is the customer's network. We do not touch the customer's network. The only thing the customer does is their IT says, okay, here is my Ethernet connection from port, let's say 21 from their switch. They're literally handing you an Ethernet cable to connect to the Cox switch. And that's it. There's nothing that a Cox will do on the customer's network. All of our configuration and troubleshooting, it's on our network. So the sales engineer is going to have that conversation with the customer and the customer's IT. What are the expectations of settings that need to be on their network? Okay. Now, topology 3, again, is a more complex installation. We do not see that as many, but we want to make you aware what it looks like. Topology 3, it's a shared wiring with the customer switch. So here we have Cox installing a CBI modem, a session border controller, and then for voice traffic or management traffic goes through the customer switch. Cox does not provide switches. So the customer's IT is the one that configures the VLANs on their switch, and is really just passing our voice and management traffic through their switch. Their switch is providing PoE to the phone. We connect the phone to the jack, and then the customer can actually connect their own device for data. Now, remember, all the different services are tagged with VLANs. VLAN 169 is data. Voice needs VLAN 269, and the management VLAN is VLAN 369. So customer must have a compatible switch and configure it to be able to work with IPC. This is also a complex installation. It's a BTT2 responsibility, but again, we want to make you aware, because if you go into the field and the issue is just a phone, we troubleshoot the phone the same way. Doesn't matter the topology. We configure the edge mark, follow the same process. Does not matter the topology. Okay. Any questions about the topology before we do this quick knowledge check? Okay. here we have, what topology is pictured here? Is it 1, 2, or 3?
One.
1, okay? Topology 1. Now, with topology 1, we see that the customer's data and the customer's voice network run on separate networks. So each station needs to have dual Ethernet ports. Okay. Next, we're going to do a review on the different topologies. So we're going to call out our characteristics, and let me know if it's topology 1, topology 2, or topology 3. So let me go say, Jermaine, voice and data uses same LAN wiring. VLAN separate traffic. Is that 1, 2, or 3?
2.
2. Yep, correct. Okay, Dustin, voice and data networks use same LAN wiring.
Three.
3. Yep, correct. Walter, what did I say is the preferred topology?
1.
1. Okay. Okay. So what topology, Christian, requires dual Ethernet ports at a station with phone and computer?
1.
1. Yep. So next one, it says require when workstation have only one Ethernet port. That, and
2.
what was it?
And that's 2.
That's 2, right? So that could be 2 or 3,
Yeah.
right? 2 or 3. But however, the answer here, we just labeled it 2 because on both 2 and 3, that means each workstation have only one Ethernet port. Now, voice and data services run on physically separated networks. Is that topology 1, topology 2, or topology 3? Okay. As we say, that is topology 1. So you have all this information on your notes on the folders that are added. Again, these are some activities that we can perform with the technicians to be able to kind of do a knowledge check. So when they go into the field and they're looking at a topology, they understand how the voice, the data, and the management and all the traffic flows through the equipment based on the topology and what are going to be some of the wiring requirements for the different topologies. Okay. This is the meat and potatoes of this module, right? How do we work with this equipment? We have, in this example, we have the HMark 2900E, which support all the different topologies. I believe on the wall, we do have a 2900 PoE. So that one has both the HMark and the switch in one, but the ports and settings are the same. So in the front, you do have 2 LEDs, a power LED, which indicates if power is applied to the device. You also have a status LED, which indicates the state of the system. Now, You want a solid green for both status and power. Once the unit powers on, it's going to go through a power cycle, and it will flash from off to amber to solid green while it reboots. It normally takes about 30 seconds to about a minute to go through its initialization process. The status LED also goes through that cycle. Now, the one thing I want to mention is that your status LED should never be red. If it's red, it's indication. If it's solid red, it's an indication that there's an issue with the operating system of the device. And even a power cycle, a factory reset, does not reset the device. So the equipment, the session border controller needs to be replaced. In the back of the unit, again, you have the same power LEDs and status LED. To the left, you do have the erase button. If you press the erase one time, nothing happens to the device. If you press it twice, and when I say twice, they have to be in session 1, 2. It's not like you press it once, 2 seconds later, you press it a second time. No, it doesn't follow that. They have to be quickly in session. Typically with those push are going to be within a couple of seconds, 1 or 2 seconds. So 2 clicks, it's going to reset the local password to log into the device, but it doesn't interrupt service. If you do 3 clicks in session and hold on the 4th, it actually does a factory reset. The first thing you're going to notice that the status LED is going to change to red. And then it's going to go through a cycle process of rebooting. So when a device is factory reset, all configurations is lost. Internet connectivity is lost. And access back to voice services can only be restored until we actually upload the configuration. You have 2 wide area network ports, or 2 WAN ports. Port 1, which is the bottom port. Port 2, which is your top port. Your backhaul goes to port 1. When we do the configuration also only configures port 1. We do not use the SFP ports for the WAN 1 or 2. LAN, these are your 4 LAN ports. Port 1 is the handoff to a switch. Ports 2 and 3 are not used. And port 4, it's the port that we use to configure or manage the device. Then we have an SD card and a console port, which we do not use. Here's the 2900 PoE. Erase, WAN. It's all the same. Configuring the device, it's the same way as the 2900 without the PoE ports. Now the LEDs on the right, they indicate if a device that is, a port that is being used has a device that is requesting power, such as a phone. So the LED will be lit if you connect the phone to it. You have 12 ports that can be used for phones. Configuring factory setting is the same. One good call out I want to mention on the 2900 PoE is that it does have a power switch, and also it does have some fans. These fans are not loud, very loud, but they do make considerably higher much higher noise than the standard 2900 edge mark, which could be a little bit loud in some locations. Any questions about the 2900 or the 2900 PoE edge mark, about the different components, ports on it? Okay. WWT does the initial configuration on the phones, the switch, and the edge marks, and they get shipped to the customers for installation by the technician. However, there will be times that a technician might go in and maybe there was a lightning strike and the edge mark needs to be replaced. This is where this training is going to be very important, understanding how to build this configuration. So in order to do that, the edge mark would automatically give you a DHCP IP in the range of 192.168.1.234, any IP address. The gateway IP to get access to the edge mark is 1.1. So when you grab an edge mark for the first time and you need to configure it, we recommend changing the network settings on the computer to 192.168.1.50. That's the IP address. The gateway is 192.1.1, and the mask is 255.255.255.0. Then you open a web browser and enter the gateway IP. A login message is going to give you similar to what you see here on the screen. The default username is root. The password is default. That's when the edge mark is factory reset. That's the default login. Okay. You will receive a message to change the password. This password is a temporary generic password. You can use any combination. Now we use different passwords. We use this password like let me see, as you see here on the screen. Other passwords that technicians have used is like cool, capital C, OOL, number 1, and @ because the requirements is that it needs an alpha character that is capitalized. It needs a lowercase alpha character, and then it needs some numeric characters and a special character. This is not going to be the final password because when we load the configuration, it will change that password. That's just a temporary password. So again, technician needs to set up their computer to be able to communicate with the edge mark. So we do recommend that once you change your IP on your laptop to match the IP of the edge mark, run a command line and do a successful ping command to make sure that the computer is communicating with the edge mark. Now the edge mark, it's ready for logging in and configuration. I have my edge mark already connected. So for example, if I type in 192.168.1.1, it already logged me in. This is because I was logged in on it before. So here is my landing page. Okay. We're going to go a little bit more in detail on navigating within the different tabs in here. So quick knowledge check before proceeding. Question number 1 says, what is step 1 in connecting to the edge mark for the first time? What should the technician be doing when they're trying to connect to the edge mark for the first time?
D.
D, yes. Right? We need to connect the computer to the LAN port of the edge mark. Now, I did mention that out of those 4 LAN ports, 1 is the port for the switch, 2 and 3 are not being used. So between ports 1 and 4, which port should the technician be connecting to configure the edge mark? 4. That's correct. Okay. Question number 2 says, when configuring a laptop for communicating with the edge mark, a successful ping command means what? B. Yep. It's ready to configure the edge mark. Okay. Now the next steps is just going to go through details how to configure an edge mark. So this slide really reference if a technician is replacing an edge mark that and verify how many call paths that edge mark is able to support. If we are doing a break and fix and we need to replace an edge mark, we want to make sure that we're replacing with a like edge mark with the number of call path. So here you have a 4550 edge mark that is able to support 70 call path. So if we're replacing an edge mark, we want to replace it with another one that can also do 70 call path. And we're going to give you instructions, and they will come up later on how we do that. Okay. To build the configuration for the edge mark, we actually need to go to the IPC configurator. This is an Excel spreadsheet document that we use to configure the edge marks. This is what creates and generates the config file. I'm going to show you how to get to the configurator a little bit after a couple of slides. But when we open up the configurator, on the top of the configurator, we're going to see all these different steps. So customer name, that will be the customer name. Account number, customer's ICOMS account number. The SBC or the session border controller, this is location specific. There will be a drop-down menu where you can select from the different markets. You want to select the market that you're installing the session border controller in. If it's Hampton Roads, Hampton Roads. If it's Nova, Nova. Then the service, this is the topology. Are we doing topology 1? Are we doing topology 2 or topology 3? If you have a 2900 PoE with a 2900 PoE edge mark, it's by default topology 1. If you have a standalone 2900 edge mark, it could be any topology. So normally that information is going to be in optics, where you can go in and verify the station review and it will tell you what topology it is. If it doesn't specify topology 2 or topology 3, assume it's topology 1. The model of the edge mark is just the model, 2900, 2900 PoE. We want to select the correct model because if we build a config for a different model than the one we're trying to use, when we upload the config file, it will reject it. On the WAN interface, select DHCP if it's dynamic over CBI. And when we're using static, it will be when we have a COI circuit. or if we are using a static IP. As I mentioned, these are going to be more of topology 2s, topology 3s, and maybe also COI static IPs. That's probably going to be a BTT2 role. But we want to make you aware that this is where we make the change for the WAN connection. Under the enable packets and share key, do not change anything, just leave it to default. And the last step is to click where it says generate HMark config file. Now, this one here just kind of walks what ports are going to be connected on these two models of HMarks for the WAN. Okay. So here's the 2900 PoE. Here are the 4550s, 4700 models, and the 7300 models. These are also called out in the MMPs. There's some variations on the 4700 and also the 7301. But if you look at the 4550 and the 2900, it's almost identical. WAN 1. Configuring the HMark. If you have a LAN ports 1 through 4, use port 4. The 2900 PoE, it could be any port. We recommend using port 1, or you can use port 4 too. On the 4550, port 4. On the 4700, port 4. 7301 is a little bit different. It's on port 1. Now, I don't see a technician working on a 7301 often because they are very, very few in between. When this was deployed, it was when we needed a high call volume HMark, 100 call path, 500 call path. So these are going to be very few in between in the market. The most common you will see is the 4550 and these two models, which are the new models. Okay. So setting up your laptop, opening a browser, 192.168.1.1. You use your password. User password is default. Username is root. And it's going to ask you to change the password. Use cool one at or any 6-character numeric alpha and special character password. That will change when the configuration is uploaded. And once a HMark has a configuration, in order to access that unit, you need your network login and also a mobile pass token. So I'm not sure if that one, how do you guys have access to a mobile pass? Or when the technician is asking assistance with an HMark, are there going to be another group supporting the technicians as far as configuring or remote accessing the HMarks?
That's what we are still working on, trying to figure out.
Okay.
Work with Roland and I guess for the different access that we're gonna need, and I'll get with Chris after that.
Okay. But since we're dealing with just a local device that we can actually configure it locally, well, all we need is the default login and default password. Once you log into the device, this is your landing page. There are some different tabs that you want to go through. Here, I'm going to bypass the slide and I'm just going to show you the one that I have next to me. So this is your landing page. The first place you want to check is what is my firmware? 15.8.2. You can also verify how many call paths that this HMARC can support. This one can do 30. We go back to my admin page. Under all these tabs, you're going to use them to configure. The first one, it's your network tab. So when we click on network, we want to make sure that your WAN interface matches your configurator. Is it DHCP? Is DHCP. That allows it for it to communicate with the modem and get an IP address. On the left-hand side, we have some additional tabs that can help to troubleshoot. Network information tab, it's going to tell you the different ports. And if you're getting an IP address, you will see Ethernet 1 with an IP address that is generated here. You can verify if you have access to the internet with some of these additional network test tools. Okay. On the slide, that's pretty much what it covers: to verify your firmware, to verify your network connection. If we are going to be doing an upgrade to the firmware, the configurator tells you the process on how to do that. So in order to update the firmware, we go to where it says firmware upgrade. The configurator is going to say, okay, this is the IP address of the server. And this is the file name that you're going to use. Everything else can be left to default, except you want to make sure you have use passive FTP selected. Once we hit submit, if my unit hasn't had an internet connection, it will go through the process of downloading the firmware. Depending on the connection, it can take from 5 to 20 minutes. I don't see the technician performing these steps. Everything once is deployed from WWT, it's already configured with the correct firmware. If we do a factory reset, it does not remove the firmware. The new HMARCs from the warehouse, they do come with the correct firmware already installing them, the one that the configurator calls for. So it's not something that the tech will perform when we are reconfiguring an HMARC. The last step, we actually will go to where it says admin and under backup and restore. This is where you will download the configuration file that was created using the configurator. I choose file, finding the file that it was created. Let me go to my desktop. Here. Okay. I created one on the 26th when I was working for this one, so I'm going to use this one. Here's my HMARC config file. It says EM for HMARC, and then the customer name. In this case, I just labeled test IPC lab. Click open. Now here it's going to say download. You're really uploading that config to the HMARC. Now the unit will say system save configuration, and it's going to tell you the config file name. The last step is to restore configuration. Once we click Save Restore Configuration, we no longer have local access to the edge mark. Now we should be able to remotely log into the edge mark using the IP address that the modem is assigning to the edge mark. And you can find that IP in VisView. Or if it's a static IP, you will have the static IP information in optics, so the edge mark can be accessed remotely. Pretty much the settings, that's all we do in to the edge mark. So all the steps that I called out, step by step, they're called out in the MMP and the PowerPoint. So it gives you, when you are working with a technician, how to perform all the steps, it tells you step by step. Okay. Now, accessing the configurator is very important that we always use the most recent version of the configurator. There's changes that are added, updates that are added, and we are only going to take care of that when we use the latest version of the configurator. Okay. So what I want you guys to do is we're going to do an activity of logging in, finding the configurator, and creating a base config file. It's going to be a generic config file. So we can practice loading that configuration to the edge mark. So, gentlemen, do you have access to Cox 1? Here, let me send you guys a link on the chat and let me know if you are able to access this that folder. Give me 1 second. Business technology. So apologize because I have to find that, go through what is the actual link to that folder. And let me know if you guys can access this. Centrics. Okay. Okay. Let me know if you guys can open that link that I added on the chat.